Today we're going to move on to the last section of this particular unit, and it is using systems to work out application problems. So it's applications of systems. You should have the paper by the door and something to write with. Okay. So kind of a guided process each time. We're going to read the problem, define our variables, write the system, solve it, and then answer the actual question. So we have to be careful and make sure we know exactly what they're asking for. Okay. All right, so our first example, it says the sum of two numbers is 51. The difference of the numbers is 13. Find the numbers. So the first thing we're going to do is determine what our variables are going to represent. So we could make x represent the first number, and we could make y represent the second number. Because all we're talking about here is two numbers. It's not like applying to anything else. Okay, with the information they give us, it says the sum of the two numbers is 51. Olivia, how do I get a sum? You add them together. So I have x plus y is 51 equals 51. The other information that they tell us is that the difference is 13. Jude, how do I get a difference? Subtract. So x minus y equals 13. So we now have our system. Now we need to solve it. So I'm going to rewrite it up top here. And now that we have learned all three methods, it is completely up to you which method you want to use, but hopefully you use the method that it is most ready and set up to use. Like right now, they're both in the same order, and in fact, our y variables, one's a positive one and one's a negative one. Annalise, which method do you think we should use? Canceling out, so elimination. We're going to use elimination. Remember elimination? We're technically adding together the two equations. If things didn't already cancel, we would multiply by something to make them cancel, but this time our y's already cancel out. So we're left with 2x equals 51 plus 13. What's that going to give us? 64. And when I divide by 2 on both sides, what's going to be the value of x? Okay, so x is 32. If you need a calculator, I'll pause right now so you can grab one. If not, then we'll move on. I just said if you feel you need a calculator, I'll pause and let you grab one. Okay. Yes. Yeah. All right, so we have half of our answer. We only have x. Annalise, how do we find y? Does it matter which one I use? No, it does not. So if I use the top equation and we do 32 plus y equals 51. To solve for y, I would just minus 32 on both sides. And 51 minus 32, what does that leave us with? 19. Okay. So if this was just a regular system, we would write it as an ordered pair. But since it's an application problem, we need to answer it with words. We need to actually answer the question being asked. So we said that x was the first number and y was the second number. So if we make a sentence statement here, the first number is 32. And the second number is 19. Again, if it had not been an application problem, we could have just wrote the ordered pair. But since it's an application problem, we need to answer with a sentence. All right, anybody still need a second? We're good? Okay. All right, let's take a look at our next example. It says Braden bought 3 adult tickets and 1 child ticket at the movie theater and paid $32. Karen bought 7 adult tickets and 2 child tickets and paid $73. Find the cost for 1 child ticket. So just like last time, we're going to determine what X and Y should represent in this problem. So this whole problem is talking about adult tickets and children's tickets. So I could say that X is the price for the adult tickets. And Y is the price for the children's tickets. I'll just say kid, children. Kid is shorter, so I'm writing kid. You can write children's tickets if you want to. Okay, so now that I know what is representing what, I'll read back through the problem and interpret what they're saying to us. Braden bought 3 adult tickets. So if that's X, then I have 3 times X. And 1 child ticket, so that's just 1 Y. And the total cost for Braden was $32, so both of those added up to 32. The other equation is going to come from Karen. Karen had 7 adult tickets. So Angel, how would I represent Karen buying 7 adult tickets? Well, isn't X adult tickets? So wouldn't it just be 7X? Yeah, okay. And then 2 children's tickets, which we said was Y, so plus 2Y, and Karen's total was $73. So one equation was about Braden's and the other one was about Karen's. Now we need to solve it. So I'm going to rewrite it kind of small up here. And again, we get to pick the method. I would probably either use substitution or elimination. Okay, so if we want to do elimination, I have to make it cancel. Right now the X's don't cancel out and the Y's don't cancel out. But I see that I could make the Y's cancel fairly easily because this Y has a positive 2 and this Y has an understood 1 in front. So what could I multiply the top equation by to make the Y's cancel? Specifically negative 2. Remember that has to go to everything in the equation. So I'm going to rewrite my new equation. That'll leave me with a negative 6x minus 2y equals negative 64. And I distributed negative 2 to all 3 items. Then I'm going to add my new equation with the other equation. 7 plus negative 6 means the same thing as just 7 minus 6. So we're left with 1x. Our y's canceled out. And 73 plus a negative 64 is 9. So X was representing the adult tickets. The actual question wants to know the cost for the children's tickets. So we need to figure out what Y is equal to. You could have, but we would have had to make the X's cancel, and I had a 7 and a 3. You could have. Harper, if I know the value of X, how do I find the value of Y? Yeah, the original equation, either one. So if we use the top original equation here, we'd have 3 times 9 plus Y equals 32. Tafe, what's 3 times 9? 27. And then so if we minus 27 from 32, Y equals 5. So the actual answer to the question that children's tickets are $5 each. If it had just been a system of equations, we would have wrote the ordered pair, but it's an application problem. You need to have a sentence answer. Does anybody still need a second? You said yes? Okay. The key is posted in Schoology, so if we move too fast, you can go back and check. Okay. All right, so taking a look at example number 3. Olivia, will you read that for me, please? All right, thank you, ma'am. So we've got our x and our y. And let's determine what they should represent with this problem. Greek, what is this problem talking about? What do you think our variables are going to represent?
The hamburgers.
Okay, the hamburgers. What else?
Fries.
And fries. So we could make x be the cost of a hamburger.
And y.
Exactly. And y would be the cost of fries. So the very first thing you need to do is determine what the variables represent, because then it helps you to be able to set up what your two equations should be. Okay, so at the fast food restaurant, 1 hamburger and 5 fries, 5 small fries, cost $8.74. Keelan, can you help me set up an equation using that? How would I show 1 hamburger? If x is hamburgers, how would I show 1 hamburger? Yes, Annalise? Yeah, I could write the 1x in front of it, or I could just write the x. Okay, what about the 5 fries, Hudson?
5y.
Okay, so plus 5y. And if the total costs $8.74, it's just equals $8.74. They're being set up almost the same exact way every time so far. The next equation, 2 hamburgers, 3 fries, is $7.75. Lakaira, what would that equation be? Exactly, thank you, ma'am. 2x plus 3y equals 775. So now we need to solve it. That will be the whole lesson, sir. My other classes. Alright, so now I gotta pick a method to solve. I could use substitution or elimination. Okay, so if I'm gonna use elimination, Quayla, which variable should I make cancel out? Which one's like really close to canceling? The x's. So the bottom one has a positive 2x. Greek, what would I have to multiply the top one by? Negative 2. So I could make that a negative 2x. So if I multiply that top equation by negative 2, our new one is negative 2x minus 10y equals, this is why I said get a calculator earlier, negative 2 times 874. Use the calculator, don't guess in your head. Negative 17.48. Okay. So let's go ahead and add. We know our x's canceled. We made that happen. We are left with negative 7y equals negative, what's 775 minus 1748? Should- 1748.
-973.
9.73?
Yeah.
Okay.
Sorry.
Alright. So the very last thing we have to do is just to divide both sides by -7.
I thought you said we could use this.
Well, if I'm... Wait, I didn't say you couldn't use decimals. When did I say that?
When did she say that? You should have told me that.
A lot of our answers so far haven't been decimals, but this is talking about money.
Well, you should have done it then.
So 973 divided by 7. What, well, it should be positive. 1 point what, Quayla? So what we just found out was the cost of
Frost.
fries.
Can we not just like
So we're just plugging it back in. Yeah, I mean, essentially. Look, dude, you're doing it in your head anyway. I'm just writing it down so you can see what I'm actually doing. So if I plug it back in, I plug it back into either one of the original equations. So it would be x plus 5 times 139 equals 874. So Chris, what's 5 times 139? 6 point what?
6.95.
Okay.
Sorry.
And then we minus 695 from both sides. We get our actual answer. 874 minus 695. That's what we're waiting on. If you need a calculator, grab you one.
1.7.
4.6.
Yes, Hudson.
1.7.
1.7. I don't know why I thought you said 4.
I think that's what Chris does.
I thought he said.
All right, so the actual answer to our question, we write it as we're supposed to. One hamburger costs $1.79. All right, question number 4. We should be moving on, about halfway done here. All right, Colton sold a total of 28 t-shirts and sweatshirts as part of a fundraiser for his football team. If t-shirts cost $12 each and sweatshirts are $20 each, and he raised a total of $424, how many t-shirts did he sell? So first of all, establishing what X and Y are going to be representing. Okay, just t-shirts? What's the other one? Okay, so X could be the number of t-shirts, and Y could be the number of sweatshirts. Okay. All right. So if there was a total of 28 shirts sold and sweatshirts sold, but I don't know how many of each, then all I can say is X plus Y equals 28. Because I don't know how many of each were sold. All I know is that a combination of t-shirts and sweatshirts totaled up to 28 total items. The other one is a little bit more obvious because it's talking about the cost per each and then the total amount of money. So Olivia, could you help me write the second equation? Well, if it's $12 for each sweatshirt and if it's 12 for each t-shirt and 20 for each sweatshirt, how would I show that? There you go. So one equation was all about the number of shirts sold. The other equation was all about the cost for each and the total amount. So now that we have our system, this is number 4. Okay, so this time both the x and the y are alone, so if you wanted to use elimination, if that's just the method you're sticking with here, we could easily make either one of them cancel out. We'll do 12 because then we'll have to multiply by a smaller number here. So if the bottom has a positive 12, we're going to have to multiply the top equation by negative 12. So we got negative 12x minus 12y equals, in your calculators, we need to figure out what negative 12 times 20. Negative what? Sorry.
Negative 36.
Okay. Alright, so we have our new equation to add with the old one. The x's cancel. We have 20y plus a negative 12y, that's just 8y. 424 minus 336. 336.
88.
Okay. And so when we divide by 8, y equals 11. So we just found out how many sweatshirts were sold. We need to figure out how many t-shirts were sold. So if I plug it back into the top equation, really it's just 28 minus 11 is what it's going to come out to be. When we minus 11, what's the value for x?
17.
Okay, so the answer to our question is that he sold 17 t-shirts. Yes, ma'am. All right, I think we got like 3 left. We're almost done, guys. And then after this, you'll work on some practice problems to see if you actually know how to do it. All right, question number 5. Caitlin has 2 part-time jobs, tutoring and working at a grocery store. Last week she worked a total of 15 hours. If she makes $15 an hour for tutoring and $9 per hour at the grocery store, and she made a total of $159, how many hours did she work at the grocery store? So, x and y, let's first establish what it's all about. So it's number of hours. One of them's going to be tutoring, and the other one is hours at the grocery store. What are you saying? A lot of people tutor for an hour. That's usually the standard amount of time. Okay. Okay. We're moving on. We're done. So based upon the labels on the variables, let's go back to the situation and make some equations. So we know that she worked a total of 15 hours. Annalise, do we know how many hours she did each yet? No. So all we can say is that x plus y equals the total number of hours, which was 15. Yeah. What I'm saying is we don't know the number of each yet, but we do know all together the amount of hours totaled to 15. So all we can say is x plus y equals 15. Her hours tutoring and her hours at the grocery store equaled up to 15 hours. Like make it colder? Oh, you mean turn it up? Okay. Yes, yes, yes. Click the button. Come on. So we have our second equation to write. Tafe, help me out. So if she makes 15 an hour tutoring and 9 an hour at the grocery, how will we show that? Okay. Okay, and what does that equal? Thank you. So we have our 2 equations. If you were looking at the board, you wouldn't be concerned with it. Okay, so this one's very much like the last one. We can pick either method.
Why?
We'll do y. Are you saying that because it's a smaller number?
Yes.
Okay,
And do
so
elimination.
we'll multiply by -9 to make the top cancel. So that gives us -9x minus 9y equals -9 times 15. What'd you get for that, Hudson? 9 times 15?
That's
1 point.
What?
What'd you say?
9 times 15, dear.
9 times 15, that's
15.
negative 135.
Yeah,
Thank
negative
you.
135, I'm sorry.
Okay. You're throwing random decimals in there. It's really confusing me. Okay. Okay, so 6x equals 159 minus 135. Okay, so we got 24 divided by 6, and we find out x, the hours tutoring, is 4. Questions how many hours at the grocery store, so if we just plug that back in, it's really like 15 minus 4.
11.
So the actual answer to our question, she worked 11 hours at the grocery. Okay, last two examples, guys. Question number 6. There's a key on Schoology for you to go back and check here in a minute, man. All right, so Rick bought a total of 8 pounds of steak and chicken. If steak is $13.50 a pound and chicken's $3.25 a pound, and he paid $77.25, how many pounds of steak did he purchase? So first of all, let's establish what X and Y is representing. So the pounds of steak and pounds of chicken. That's LBS for pounds if you're wondering what that is. All right, based upon the first sentence, Rick bought a total of 8 pounds of steak and chicken. I don't know how many pounds of each yet. I just know altogether it was 8 pounds. So Smith, how could I write that first equation? Well, it's not all being multiplied together, right? It's just x plus y, and it totals to 8, right? So it would be x plus y equals 8. So that first equation was just based upon the total number of pounds purchased. The second statement says that steak was $13.50 per pound, chicken $3.25, and a total cost of $77.25. Jude, help me set up the second equation. Okay. Chris? Okay, Tori, I see your hand way over there. What do you think? Yeah? Exactly. It's like the same as the last 3 problems we've done. Thank you, Tori. So we have our system. Luckily, the first equation keeps coming out pretty simple, and it's making it a lot more obvious of what to do.
That's what I've been meaning to talk to you about.
What?
On the test, it be coming down as hard equation.
We're building up to it right now, ma'am. Okay. So this time, I'm going to use substitution because I want to remind you how that works, first of all, but also because I don't really want to multiply by a whole bunch of decimals to the top equation. You could still use elimination. You could multiply the top by -1350 or -325. That still works. But I want to take this opportunity to remind you how substitution works. So for substitution, I either have to have x equals something or y equals something. So if I look at that first equation, I could either move the x over or move the y over. Either one would work. Say I choose to move the y over. If I minus that positive y from both sides, my other equation is x equals 8 minus y. I am doing substitution because if all I do all day long is elimination, that's all you're going to feel comfortable with. Well, that's not right, because on your quiz you have to show some substitution. So now, okay, some of them are going to say solve by this specific way and prove you know how. Okay, so now that I have something that x is equal to, if x is truly equal to 8 minus y, then in my other equation where the x variable was, it will be replaced with 8 minus y. So let's set it up. And the x variable's gone because we're replacing it with 8 minus y. We're using substitution this time. So if I distribute 1350 to both things, I'm going to need to figure out what 1350 times 8 is. 108 even? Okay. And then 1350 times negative y is just minus 1350y. And if we bring down the rest of our equation, we have plus 325y equals 7725. On the left side, we have like terms, so I need to find out what negative 1350 plus 325 is. What now? Negative 10.25. Confirmed?
Yeah.
Okay.
Yes.
Yeah, tell me what I need to do, Greek. I need to move this 108 first, right? So we're going to minus 108 from both sides. Need to find out what 7725 minus 108 is.
Oh.
Negative
30.75. And then now, since negative 1025 is the coefficient, we're going to divide both sides by negative 10.25. Well, write all on the sides. This is your paper. Shh, guys. What do we get when we divide? Should be a positive number. 30.75 divided by 10. Negative 3.
Negative 3.
Okay, first of all, it's positive because we divided a negative by a negative. So the answer is at positive 3. Okay. So what we just found out is how many pounds of chicken was purchased. So since our first equation is really simple, 8 minus 3 will tell us the amount of steak.
which is 5.
So it's 5.
Oh, that's why.
So the answer to our question, we need to make a sentence and actually answer it. So Rick, it's a guy here, we got, he purchased 5 pounds of steak. Okay, last question, guys. All right, so this is the one that in the beginning kind of stumped some people, so pay close attention. And it has a collection of 45 nickels and quarters worth $8.05. How many nickels does she have? So, first of all, let's establish what X and Y are going to represent.
Nickels and quarters.
Okay. You're just thinking of how can I do it in my head and not write it down. You're still doing the same math. You're just trying to do it in your head. Okay, do it on your own and see if you get the same answer then. Okay. Okay, number of nickels, number of quarters. Okay. So, I don't know how many of each Anna has, but I do know altogether there are 45 of them. So my first equation should be just simply x plus y equals 45, because I don't know how many x's or how many y's yet. I just know together there are 45. Now the other equation, they're not going to tell you how much each is worth because they're assuming you know how much a nickel and a quarter is worth. So a nickel is worth 5 cents, so that's 0.05x. A quarter is worth 25 cents, so that's plus 0.25y. And that all equals up to $8.05. Well, that's our system. Okay. So on this second equation, if decimals freak you out, can't I just technically move all of these two to the right?
Please don't do that. That's not
Okay, well you don't have to, but that's a suggestion. If you wanted to, you could have made, it's really like multiplying by 100. But since Greek's freaking out, I'll leave it the same. She said don't do it, I won't do it. Okay. Alright, so on this very last one, I was saying multiply it by 100 to make it cents instead of like having those decimals. Like 5 cents, 25 cents, 805 cents. Anyhow, this last one I'm going to take a chance to do substitution one last time. So if we use substitution one last time, I have to either have x equals or y equals. So since last time I moved the y over, this time I'm going to move the x over. If I minus x from both sides, I have the equation y equals 45 minus x. Now that I have that, I'm going to take that expression, 45 minus x, and if it's what y is equal to, it will replace y in the opposite equation. So I'm going to bring down and set up the equation. Again, the y is no longer there. We're replacing y with 45 minus x. And now we just need to distribute and solve for x. So 0.05x, and then what is 0.25 times 45? 11.25. And then 0.25 times negative x is just minus 0.25x. And that all equals 805. On the left side, we have like terms. So 0.05 minus 0.25 leaves us with what? Negative 0.20? And bring down the rest of my equation. From here, what should I do next, Olivia? Okay. Minus 1125. So I'll get negative 0.20x equals 805 minus 1125 gives us a negative something. 805 minus 1125. Negative 3 point what? Okay. And so if I divide both sides by negative 0.20 or negative 0.2, what's the value of x? Should be a whole number. Okay, because it was a negative divided by negative, it should be positive. So we just found out there are 16 nickels. That is actually the answer to the question. If they wanted to know how many of each, we would have to plug it back in to find y, the number of quarters. But this time we hit it the first time. Well, I hope you can show your work for that on the quiz or test. So, Anna has Don't tell me you smash buttons in a calculator. That ain't gonna cut it. Anna has 16 nickels. Again, this time we had our answer the first time, so we didn't have to plug it back in. If they wanted quarters, we would have to do that. All right, at this time, you should have a practice assignment showing you red or green in the computer. Let's go ahead and start that. We'll submit at the end of class. You do not have to finish that.